Students, today we will start exercise 2.4 of chapter number 2. Before start the exercise, there is a concept of factor theorem. What factor theorem says, if px is a polynomial of degree n greater than equals to 1 and a is any real number, then x minus a is a factor of px if p of a is equals to 0 and p of a is equals to 0 if x minus a is a factor of px. Now this is nothing, this is just related to a remainder theorem. Remainder theorem में हमने क्या पढ़ा था, अगर px is a polynomial, एक polynomial है and a be any real number, then if we put the value of that real number in the polynomial, the answer that comes is the remainder. And factor theorem is related to that. If the answer that comes, the remainder that comes is 0, it means the linear polynomial is a factor of the polynomial. Otherwise, it is not the factor of the polynomial. For example, if I'll take x square minus 2x, right? X square minus 2x. This is a polynomial. Polynomial in x. If px is a polynomial of degree n greater than equals to 1, degree is greater than 1. And a is any real number. Let it be a is equals to minus 2, where minus 2 is a real number, right? Now, x minus a is a factor of px if p of a is equals to 0. P of a. Now, if we find p of a is your minus 2 square 2x. That is 2 of minus 2, right? Here, let us take this minus 2. Now, p of minus 2, minus square is plus and 2 square is 4. And here it is minus 4. The answer is 0. If p of a is equals to 0, then we can say that x minus a is a factor of the polynomial. X minus a. A is your minus 2, minus 2. Minus minus plus, x plus 2. It means x plus 2 is a factor of this polynomial. X plus 2 is a factor of the polynomial if p of a is equals to 0. Now, a real number is minus 2 and p of minus 2 is 0. It means x minus a. X minus a means x minus of minus 2 minus minus plus x plus 2 is a factor of the polynomial. And vice versa also. If x minus a is a factor of the polynomial. Again, if x plus 2 is a factor of the polynomial, then x is equals to minus 2 will be 0. Then x of p of minus 2 will be 0. So this is our factor theorem. Now let us start with exercise 2.4. Question number 1 is, determine which of the following polynomial has x plus 1 a factor. Now there are 4 parts given in the question. I am doing first part and fourth part. Second part and third part we can try yourself. Now first part is there, x cube plus x square plus x plus 1, and we have to determine whether x plus 1 is a factor of this polynomial or not. So what we have to do? We have to equate this linear polynomial with 0 and find the value of x, that is minus 1. If p of minus 1 is the 0, it means this x plus 1 is a factor of this polynomial, otherwise it is not the factor. So x is equals to minus 1. P of minus 1 is equals to minus 1 cube plus minus 1 square plus minus 1 plus 1. Minus 1 cube is minus 1 plus minus 1 square is again plus minus 1 plus minus minus and plus 1. This minus plus 1 cancel, minus 1 plus 1 cancel. So answer is 0. Now if p of real number, that is p of minus 1 is equals to 0, so yes, x plus 1 is a factor of the polynomial. Now again the value of x is equals to c and we have to put the value here. P of minus 1 in fourth part, minus 1 cube minus minus 1 square minus 2 plus root 2 of minus 1 plus root 2. Now minus 1 cube is minus 1 minus minus 1 square is 1 minus minus plus 2 into 1 is 2. Root 2 into 1 is root 2 and plus root 2. Minus 1 minus 1 minus 2 plus 2 plus root 2 plus root 2. Now this minus 2 and plus 2 will be cancelled out. Root 2 plus root 2 is 2 root 2, which is not equals to 0. It means x plus 1 is not the factor of this polynomial, right?